Hello, everyone. Everyone doesn't look quite awake. I know it's 9:30 and we're software engineers, but it's time to wake up, guys. We'll try to make this a fun talk. I'm Akshay. I'm an engineering manager at Meta, working on our productivity insights team.
I'm Kelly Hirano. I also work in dev infra alongside Akshay. Hopefully earlier today, or yesterday, I guess, you all saw Kareem and Rui's talk. I think they were great. Hopefully you all enjoyed it. Today's managers talking, so it's a little higher level, less accurate, but we'll try to frame a lot of what they had talked about. So we're part of dev infra, and I think dev infra is part of infra, and we're probably the most product-oriented team in infra. And so as a result, we have a vision statement, and that is to create a new era of engineering that amplifies developer creativity. We're really lucky because Meta has invested in dev infra early on, right? We're founded by an engineer. The notion of engineering as a craft is very important to the company, and infra and dev infra have had the benefit of investment from early on, so we don't have to fight for that as much any longer. So as we think about developer productivity, all of you think about this stuff all day long, but to take a step back, one way to think about it is to think about what are the challenges that we have and what are the assets that we have to deal with. So every company, big and small, has their own unique challenges, and Meta's no different. But for us, a lot of that is scale and diversity. So first of all, we have tens of thousands of engineers across the spectrum of work that they do. They work with over a dozen programming languages. They're globally distributed, working from home and in offices. The interesting thing about the working from home part is Hans talked yesterday about downloading dependencies. And one of the things that we discovered is that people working from home have lower ISP download speeds, and that actually caused some problems for us too that we had to address. So that is not just a return to office kind of thing. There's actually technical challenges there too. Hundreds of device types we have to deal with, obviously all the flavors of Android, but we also have things like Reality Labs, AR devices, VR devices, those sorts of things. And one of the things that we always try to do is invisibly scale all of our work to our billions of users. We have a lot of changes that we have to deal with. So it's hundreds of thousands of changes a day, continuous deployment in some spaces that we have. There's billions of lines of code. And we have all these different targets. I kind of mentioned this, right? The obvious ones like Android, iOS. We have one called www, which is all of our web tier. And then ASIC, firmware, and these other things. I mentioned AI and ML here in research too. So we have machine learning researchers, machine learning engineers. MLRs are kind of out of scope for this conversation. They have a quite different workflow. But fundamentally, what we've learned is that engineers want the speed and ease of a startup at meta scale, which is not easy. So as we look at dev infra and what are all the things that we have to work with, we have a lot of common problems that all of you all have, or common components. So we have things like task management, source control, all these things, code authoring, code review, build, test, CI, outage remediation, and sentiment surveys. But I mentioned before that we are kind of like a product team also. So we have some of the components of what a product team has. So some of these things might be less common for a lot of other teams. So we have data scientists and data engineers. We have user researchers, designers, PMs. How many people have PMs? I've heard that's a thing. We have research SWEs like Rui. We have MLEs, machine learning engineers, and machine learning researchers that we get to work with from our Gen AI group that are working on cutting edge llama work, for example. We have language developers. We own the hack language and have to think about how to make that work effectively. We have compiler and compression experts. These folks save us megawatts every year of capacity, so we don't have to buy more hardware, buy more efficient compilers and profile-guided optimizations and what have you to make our binaries smaller. We also have this productivity insights team. This is what Akshay and I are part of that get to focus on work like this. And the other thing that we get to do, and we'll talk more about this a little bit later, is impact-driven prioritization. So we really look at cohorts that we want to work on to be able to have the most business impact at the end of the day. So given all this sort of stuff, where do we start as we think about developer productivity? So, looking around our wikis, every team has all these different ways of thinking about things, right? We have Fabricator, which is our code review tool. They have a way of thinking about, changes that are unpublished and all that sort of stuff. Kareem talked about CGT yesterday. We have inner loop and outer loop. There's all these different tools that are in part of the inner loop and the outer loop. We have things like UCT, can't remember what the U and CT stands for, cycle time, and then there's an end-to-end one, there's a calendar one. There's all these things. Every team has different ways of talking about how they measure their own productivity. And what we realized is that without a common way to describe the problem, we can't effectively talk about it or even solve it. Everybody kept talking past each other. So I was mentioning earlier that we have, So we have this notion of canonical, right? How do we get to a canonical way of talking about all of this stuff? I mentioned earlier that we have user researchers. So our user researchers worked very closely with us and came up with this, right? These are what we call the stages of the developer journey, the highest altitude. And so this is now the common language that we use when we talk about our work in terms of investment, in terms of team orientation, and that sort of thing. Sometimes we need to go a little bit deeper. And so we have what we call a medium altitude towards all of this. And so, for example, under plan, we have things like coordinating and managing work, technical design, and these darker black areas are kind of a little bit cheat at the next level down, which is sort of jobs to be done and or tools. But then create a diff, we have code authoring and code verification, review and land, code review, continuous integration and land, release, and monitoring, investigation, and mitigation. So this orientation also helps us with things like our sentiment survey, right? So our sentiment survey, we are now able to kind of categorize based on this medium altitude of the developer journey and correspond it to the higher level. All of this framing helps us connect everything. So then, now that we have all of that stuff, we also need to think about, for a given ecosystem, as we call it, Android, iOS, www, RL, Reality Labs, and AI as examples, we have to think about how do we adapt our platforms to those ecosystems to actually have them be successful, because the platforms don't necessarily have that notion of that end-to-end experience. So we have a developer experience, or DevX team, that does this, right? And so for a given workflow, we have what we call a supported workflow. This is a screenshot from a tool that has sections that cover all these other sorts of things, but it says very clearly for a given workflow, and I think this is our www workflow, this is the things that we support from a CD standpoint. And so it's color-coded, right? So that both we and our customers can have an expectation that anything that's green is going to be awesome, right? If they go off of green, then it will be less awesome, and they could be on their own, or maybe something that we have to develop. We've also learned that this is not something that we can just dump on people, right? This is something that we have to have a negotiation, understand what their business needs are, understand what we can do, and kind of have this handshake negotiation. But this is something that's proven to be pretty helpful for us. Oh, interesting. And we also are doing this for language support. So we have posts that we make that talk about the supported languages that we have, the supported IDs that we have, to make it very clear to the developer community what it is that they should expect from us. All right. So with all of that, we've also learned that we can't solve everybody's problems. And so we have to think about how can we deliver the most impact and solve sets of people's problems, because given the diversity that we have, it's very difficult to attack the whole population. So we all have surveys. This is a redacted version of a hypothetical survey dashboard from our group. And so you can see in general, blue and darker blue is higher sentiment, red, orange is lower sentiment. And so in this case, this is a tool that's available to all engineers in the company, or everybody in the company. And in this case, we've done a split by language. So the columns are by languages. And we also can do splits by repo, IDE, ecosystem, tenure, IC level. These are the things that managers want insights into so that they can understand how to go and attack these problems. And it helps us understand how we can go and attack these problems. It also lets us see things across all languages, for example, that there's areas that we are not that great. And for a given language, we can see that for C++, we are generally not that great in this fictitious example. And so one way that we've gone about this is saying, okay, well, let's dig in deeper and look at our C++ section. There's a question in the survey that corresponded to this area. And it reads, in the last 3 months, how satisfied or dissatisfied have you been, blah, blah, blah. You can read this, right? With a set of questions. And we did this for every language, and C++ for us was consistently low. Now, this isn't to say that we do a bad job. C++ at our company is very challenging when you have millions of lines that you're trying to index as fast as you can to make it very available to the IDE right away, right? So the IDE team saw this problem, and their first instinct, which makes sense, right, is to come up with a bunch of metrics to the systems that they own to try to improve them, right? Some of these kinds of things might look familiar. right? Like trying to monitor and improve the percentage of C++ files successfully opened and fully functional with fully functional language services. Language services mean, again, autocomplete, go to definition, these sorts of things. So they came up with all these sorts of things. And as we started talking about this, we said, okay, well, if you do all these things, does this actually affect the user? Like, will they have a better time the next time? And it wasn't clear, right? So then there's this one senior IC. By the way, if you don't listen to your senior ICs, you absolutely should. He asked this question. He said, come up with a metric that actually represents the user pain and drive that down, right? And we started calling this the user empathy metric. And so we converted all of that into this thing that's called the user perceived navigation disruption, UPND. And what this does is it quite simply takes all of the within an ID navigation actions, makes that your denominator, all the failed or slow ones as your numerator, and it shows that percentage of the ones that are all of your disruptions. By doing that, it allowed us to normalize all of this. And this is a histogram of people that have these bad experiences, fictitious, bad experiences, right? So you want it to be lower and not higher. By normalizing it, this did a lot of things for us. One, it allowed the teams to be able to prioritize their work and say, hey, if we did this work, given that we know the numerator denominator, it will affect UPND by this amount. It allowed us to cut by languages. It allowed us to determine what sort of good was, because we can look at all the other languages and see what percentages ended up of UPND ended up driving more good comments, more bad comments in our sentiment survey, higher sentiment, low sentiment. And we also discovered that at around 20% or so, that had a step function increase in the amount of negative comments and lowered satisfaction that we got. It's not precise, but it gave us enough direction to be able to orient towards what we wanted to get to. It's also pointed out obvious things like there's some people that have a really, really bad time over here. And so we had to dig into that, and that ended up being a cohort that we might have missed had we not done this analysis. So with all that, I'll turn it over to Akshay.
Cool. Thanks, Kelly. Now we talk about the stuff you guys actually came here to listen. No, I'm just kidding. We'll talk about our framework and measurement and what kind of metrics we use that came out of some of the cohorting and framework that Kelly talked about. So Meta is very, very data-centered. Every decision we make is based off of data. If you're getting Thai food on Tuesday in the cafeteria, somebody looked at the data to make that happen. So the data-driven culture of the company is, you see it very commonly in product teams, but you don't always see this in infra teams. So this is something we actually really, really deeply care about. And like Kelly was saying, we have data scientists that work as peers to the engineers. For dev productivity, we came at it with the same lens. Let's have data scientists work really closely and see what magic we can do. So turns out it's not that simple. I stole this slide from Kareem, if you didn't listen to his talk, but the idea here is we think about our metrics like a product team would, right? Like you have top-line metrics that impact the business. You have driver metrics and empathy metrics that actually can correlate with them, that drive the top-line ones. It gives organizations an easy way to find metrics that can impact the business without, directly influencing it. And the last one is operational metrics. These are things teams care about. So what we do here that I think is very interesting is we don't have infinite data scientists. We can't put them on operational metrics. So we put them on the L0 and L1 metrics because they impact the business. Generally, engineers and data scientists have different skills, fairly unique skills, and they don't jive really well, right? Engineers don't do DS things really well, and data scientists don't do engineer things really well. That's just the reality. But for something like operational metrics, what we find is it's easy to get engineers to just barely cross over into that threshold of being a data scientist, get them to build the metric, work with the data scientists to get some lightweight validation done, and voila, now you have a metric like build latency that you can tie to something like developer flow pretty easily. This is really powerful because now the engineers can deterministically say, this is my impact, and that's how our product teams work. Let's jump into our framework here. So the general way we think about productivity is we have 4 big areas: velocity, quality, sentiment, and output. So we drew them out as 2 boxes here. The 2 of them are goaling. These are things that are bread and butter. We care about them as infra. We care about them as engineers. And velocity and quality are key to a lot of decisions we make within infra. output and sentiment. These are fairly unique to us. We'll talk about them shortly, but output and sentiment we look at as observational metrics. Teams don't goal on them, right? I mean, you guys all know this. You can't goal on survey results. It doesn't work. But they're really interesting to look at and derive drivers from. So we'll dive into each of these areas. All right, so this is a deeper breakdown of specific metrics and the user journey that Kelly was talking about that we use across the company. I'll stop here for a second if anyone wants to take a picture, and then you'll see the slide repeat itself as we dive into each box. Cool. All right, so mapping this back to our framework, let's talk about velocity first. This is where we spent a lot of our time figuring out the right metrics. It helps our business. You'll see 5 boxes here, right? They're split up by the stages of development, like Kelly talked about. Percent time coding. This is relatable to everyone. Ideally, you don't want to spend too much time planning. You want to get to writing code. So one way we think about this is like, how much time are we optimizing for engineers so that they can code, they can do the thing that they enjoy. Time spent coding per diff is the authoring experience. There's a lot of nuance on this one. I definitely recommend listening to Kareem's talk from yesterday where he deep dives into these metrics. I don't have enough time to go over them today, but we'll also have a podcast about that one if you want to listen to it. Diff processing time. I'll go into detail. There's a lot of interesting stuff here, but this is the linear sum of time where someone creates a diff and to where it lands. This is where we can optimize a lot of our user funnel. Diff release time. This is the amount of time it takes from someone hitting the land button to a user actually getting that diff. This is really important to us, right? I mean, we have, like Kelly said, hundreds of thousands of changes, and we need to get them to users quickly. We're experiment-driven, and having a quick feedback loop for our product teams is critical. So we rely on this to know how quickly releases are going. And the last one is, how do we mitigate outages? Everyone has outages. The goal there is to resolve them as quickly as possible, and that's the metric we look at. I'll dive into velocity, specifically diff processing time and authoring time here. So here's how we think about diff processing time. The idea there is that there's individual teams in the company that work on each part of this flow, right? And these are a mix of behavioral things and machine things. And if you're looking at this as a product again, you have to do both, right? Like everyone knows the standard stuff, make builds faster, make CI more reliable. There's a lot more interesting stuff here that we normally don't look at, but we can now with this metric is how much time are people spending in review? Turns out this is the largest amount of time that it takes for engineers to actually land their stuff. Same with accepting. The second largest portion of this is actually the diff being approved, but nobody landing it because you context switched onto the next thing. And sometimes that ends up being longer than the actual review was. But when we look at these metrics, we can now break them down and we can have engineers singularly goal on driving these down. And they have a huge impact to the velocity that we see across the company. So if there's anything you take away from here, let's say, think about your developer flow this way. It's a user funnel. How do you optimize it is extremely important. Authoring time, this one's complicated and hard. This is the amount of time people spend authoring a diff from the start of their command into the IDE, and we are now FN Tech. But authoring time is a very interesting one because it's non-linear. It doesn't really fit into this model well because when you're authoring a diff, you send it, someone has to review it, you may need to make changes. So authoring time is non-linear compared to DPT, but if that is something that's interesting to your organization, I definitely recommend it. It's a hard thing to do, but it's extremely empowering because then you can break down things into how much time am I spending in the IDE? How much time am I spending looking at documentation? And then you clearly know where the user is spending that time. Let's jump into quality. So this is a super cool one. I love this one because I think it's fairly unique to us, and there's a lot of cool learnings I want to share. So there's 4 big areas here. Code quality, a lot of you know about this one. Risk score, which is very unique to us. Test health and product quality, we're not talking about today. Don't have enough time, and maybe we'll talk about it at a future conference. I'll jump into code quality. So code quality score. This is something we use internally. A lot of you are probably rolling your eyes and saying, what the hell? How can you do this? Think of this as a linter that we've run through data science. Standard lint signals that people are used to, we've correlated them with some of the L0 metrics that we're talking about. So what type of lint signals are driving velocity? What type of lint signals are actually helping prevent outages? When you take a subset of those lints, you now have something really powerful, right? You can now create an incentive system of reducing tech debt by just having a score that has been validated by an army of data scientists. So you see a few samples here. I'm not going to read through all of them, but we find these incredibly powerful because this is a metric that you don't need an org to drive, right? We have a huge culture of better engineering at the company. This is engineers just refactoring code, cleaning things up, and getting rewarded for it in performance. And when you come at it from this lens, it's cool. You have organizations that can look at the health of their code base, which you can correlate with sentiment, but you also have engineers that can just take this on and drive the number down and get rewarded for it. Lints are not always fun, but it turns out when you put a data science lens on it, they're pretty cool. Risk score, this one's unique to us. Really did a great talk about this yesterday. We also have a paper. I didn't put a QR code, but if you look up risk scores, you'll find the paper. This one is also very unique to us. We like to move fast, as everyone probably knows, but we don't like to break things anymore. So that changed. And part of not breaking things is how do you communicate to the user that if you're moving fast, you need to pay attention to things. That's what risk score kind of lets you do. We use LLMs to try to predict the risk of your diff causing an outage. I'm not going to go into details of how that works because that is Rui's job, and it will take a lot longer. And but there's a few interesting things that this does, right? You can show the risk score, great, right? The engineer has a signal, but everyone likes talking about shifting left today, thanks to AI. Interesting thing that this does today is you can now give engineers a list of files that you know in advance that are going to be risky, right? Every senior engineer here knows that there is a part of their code base that's a dark corner that you shouldn't touch. But we can actually see this now with the real score and say, hey, you should go refactor this. Go add a test. And you can see the score go down, which is great because it actually enables you to move faster because you have extra safety now. We use this in our code freezes, and an interesting outcome of this is if your code is low risk, the code freeze doesn't matter to you. You can land the code now. So you actually end up getting velocity if you pay attention to quality, which is a really cool outcome for us. I'll jump into sentiment after this. This is the one everyone here knows, right? We're doing everything. Everyone else here is this. You're not going to learn a ton from this one. Sorry. We run a survey just like everyone else. We do it twice a year. We've been doing it for over 6 years at this point. That's as far back as I could find it. So if it's longer, I don't know. We also try to dedupe them so engineers don't get survey fatigue. This is all stuff that you can relate to. The things that are unique to us, Kelly talked about empathy metrics, right? There are a lot of things that you don't need to wait for survey results to get. And these empathy metrics have been extremely powerful for us. So an example I have up there is CI reliability time. Again, we applied that DS lens, and turns out CI reliability strongly correlates with our CI sentiment. This is really cool for the CI team. They can now focus on having great reliability, and they can expect sentiment to either be stable or improve. They also now don't have to rely on a laggy signal and can use that as a goaling metric. We do the same thing with other areas like planning, where turns out if you have more focus time, right, your sentiment's going to be higher. But focus time you can goal on, sentiment you cannot. So we ask teams to think about empathy metrics a lot because it enables them to move a little bit quicker. So we're not saying get rid of the survey. We're just saying find complementary things that let you assess things without the survey so they work with each other. The last one that we haven't done a lot on, but it's interesting, is support load. Like Kelly said, we have a lot of engineers. A lot of our infra engineers spend a lot of time supporting product engineers, and that is a huge cost. And something we look at is how much time are they spending responding to questions, framework questions, how can that be improved with documentation, et cetera. And that helps teams do the right prioritization. last but not least, at least output. You'll probably roll your eyes at this one. That's okay. Hear me out for a few. I know counting the number of diffs someone's writing isn't great, but we've learned a bunch of things here that I want to talk about. So this is basically the number of diffs an engineer writes per month, right? We all know this is a terrible metric to goal on. We don't goal on it, but we have learned a lot of interesting things from it. Again, that narrative of applying data science on this. We found that we can use output to find a lot of interesting drivers of culture in the company. So while you don't goal on output, the drivers of this are actually really interesting and relatable for a lot of people. So we break them up into 3 categories, right? What are things that people can do faster? Executing roadmaps. Turns out having fast review times, incentivizing engineers to hit that accept button quickly after someone approves it, and having technical managers that are involved with their team's roadmaps and understand their pain points when they're deeply involved with their, not reviewing PRs, but understanding what their pain points are. Turns out the teams can actually produce a lot and move faster. Team norms. This one actually kind of annoyed me, but it's all right. I can't fight data. Project management is good. Wow. Yeah. So we've seen that the teams that use project management actually have a faster velocity and they have higher output than the teams that don't. This is super interesting because it doesn't say that project management is good, right? That's not the causal relationship, but it does show a behavior where teams that care about how they operate tend to move faster and have better output. So we try to incentivize that type of behavior. Focus time, I won't talk about this. Everyone knows about this one. It correlates with output deeply. The other 2 are about team structure and organization. And having what we see with code reviewers is interesting. If you have one person on your team that is in the top 10% of your cohort of reviewing code, the whole team moves faster. This is a super cool network effect that we end up seeing, and we try to incentivize it across the board now. And the ramp-ups for new hires, you've probably seen this at many DPE talks now, and I won't go into too much details. But yeah, the big takeaway for me on output is don't goal on this, but it actually tells you a lot of interesting things about how your company behaves. And if you look deeply enough, the behaviors are what you can drive from here. And yeah, Kelly will talk about some takeaways.
Thanks, Akshay. So 4 takeaways from today. So 1, getting to that canonical version of the world, right? Because it's very difficult to solve the problem if you don't have the same language. The second one is intentionally prioritize user cohorts. So you saw that histogram. You remember what we saw, like there are some people that had a really bad time that we might not have seen otherwise. Another one is laddering metrics to help teams focus on what they can drive. So that was the pyramid. Kareem talked about this also. But yeah, having those driver metrics and separating those from operational metrics were super helpful for us. And then finally, having those, so that's separating the kind of things that you goal on from a metric standpoint and things that you have as observational or guardrail metrics to make sure that you are not messing things up along the way is super helpful. So, yeah, hopefully this is interesting. We don't have time for Q&A, but if you want to catch us after the conference, please do, or you can contact us through our email addresses here or through the app. Thank you.
Thank you.